Hello everyone, welcome you all back to the subject of industrial engineering and management. This video will continue with what we have seen in the previous video of unit 5. So the topics which have been marked in red are the ones which we will be discussing in this video. Value engineering, just in time and total quality management are the topics which will be covered in this video. What is value engineering? It was earlier, moving on to the history of value engineering. In 1961, this term of value engineering was coined by the person which is Mr. L.D. Miles, who defined value engineering, and he also defined value analysis. Both of them have, it was initially defined as value analysis and then it moved on, upgraded to a version of value engineering. So it is an organized creative approach which has for its purpose the efficient identification of unnecessary costs. So the cost which provides neither quality nor use, life, appearance or customer features, which that is how he has defined it. To put it on a simpler terms, he defined value engineering as the approach through which you can identify any unnecessary costs and ensure that the process is more optimized towards eliminating of those costs. So the American Society, which is the Society of American Value Engineers, called as SAVE, it defined value analysis and value engineering as the systematic application of recognized techniques to identify the functions of a product. More importantly, it focused towards the primary functions of the product and through which you can provide those functions at the lowest optimal cost. History of value engineering moves on again back to the period of World War II, where the Americans were finding it very difficult. It was as similar to the concept of Lean and Six Sigma in the previous video which we have discussed. There were most of the concept which was evolved during the concept period of World War II, where many scientists were working upon different concepts of ensuring that the defense army or the American defense is not finding any shortage of materials. General Electric, the one of the most famous company in US, it found that many of their substitutes have better or equal performance at a lesser cost. So engineer Mr. Lawrence D. Miles, fondly called as LD Miles, he started an effort to make the concept more systematic and more efficient way. So that is how the evolution of value engineering happened, and later on in the year 1959, and the establishment of Society of American Value Engineers, shortly called as SAVE, it was formed. So how do you differentiate value engineering and value analysis? They are quite commonly used interchangeably, and but in traditionally we see value engineering, it has been referring to the design stage, whereas value analysis, it has been referring to the existing product. So to make it on a much more broader aspect, value analysis is usually applied to a product which is already in the market, and you put that you put out certain criteria, you put up certain process and find out the possible ways of improvising the current or existing feature of the product to make the product much more in a more attractive way. Whereas value engineering is completely applied to a new product starting at the design stage of the product. So it is considered to have a good value when you see that the product, I keep on repeating this again and again. In an industrial engineering concept, when you speak about product, it includes your manufacturing product as well as your service product. So where value engineering, when you consider a product to be having a good value, if it has a certain appropriate performance and cost, and you also see that it can be increased by either the value of the particular product. It can be increased either by increasing its performance or decreasing cost. So both the options are possible. We usually see the perceived cost, right? So we see that application of value engineering and value analysis incur so much of cost. But to put it on a more clearer perspective, you could see here the benefits much more higher when compared to the cost. So it's not about investing something in for doing the analysis. It's about the benefit you are reaping after it. So the perceived benefits of implementing value engineering is huge when compared to the cost which is involved in it. How do you define value first? Precisely, it is always increased by decreasing the cost, and in a more precise way, it is the minimum money which has to be expended in purchasing or manufacturing a product to create an appropriate use for esteemed factors. That is how you define value. So the least amount, or probably the minimum amount you spend on a particular process, or either through manufacturing or to purchasing or to creating or designing, whatever it is. So in the process, what is the least money you are spending in to ensure that the product is meeting the required or it's meeting its efficient or appropriate use for esteem factors. That is how the value is defined. To calculate value, it is very simple. The ratio of function to cost, and the value, it refers to what the product is worth to the customers, and function, it refers to the properties and the qualities of a product. Cost here refers to the money, and it refers to the money which is spent for the materials, the labors, the direct costs, your indirect costs, all those stuffs comes into this play, right? So how do you create a job plan for value engineering? It is a more systematic procedure, as similar to all other engineering concepts we have been discussing. It is a very systematic procedure, and it usually have different multi-stage of procedures to be followed. So it was a 6-step procedure when LD Miles initially started off with. So the modern version obviously have 8 steps because 2 more steps have been added to it. As I said, most of the topics you could see that in now all the previous videos and previous units which we have discussed, we get to see that most of the uh, uh, procedures and the systematic approaches which have been designed or which have been derived earlier have been upgraded. It is because, as I said, the lean is the concept of lean itself is very clear that there is always a scope for continuous improvement. So you cannot fix to a particular procedure stating that this is ideal procedure. As the as years goes by, and the situation and the market demand and the customer expectation, all these things keeps on upgrading. You see that every version and every system, every approaches and procedure gets to a modernized version, and hence why the job plan of value engineering is also upgraded from 6-step procedure to 8-step. So we'll see about one by step in detail. Orientation phase, and it is the initial phase where the concept of ideas and where all these selection of problem and selection of ideas will be originating, and the evaluation and planning for the specific project ought to be done in this stage. You have to know where you have to head to, where are we heading to, and what is the plan, and what is the project, what is the team you are going to follow. All these things have to be clearly defined in this phase. Second phase is about information phase, where all the data is related to the present methodologies, inclusive of design, inclusive of manufacturing, all needs to be collected, and it includes all the specific function of a particular item in a product too, right? So the third phase is about speculative phase, where you have you come across different alternatives. Usually this is achieved by brainstorming. In most of the industries, you have this concept of quality forum and quality circle, right? A formal informal group of team of a few workers who just join and who just sit together, discuss about the problems they face, discuss about the objective in which they are working in. All those stuff they will be start discussing, and through that they will be able to bring in different ideas. Ideas here refers to the alternatives of doing a work. Say for example, there are 3 persons who are planning to do a work, and every 3 person will come up with this own unique idea of doing the same work. The next phase is about analytical phase, where you examine all the possible alternatives. You choose whether this alternative is feasible, or whether it is ideal, or it can be practically possible done by the team. And most importantly, you have to evaluate that in terms of cost, whether the particular alternative which you have chosen or which you have been selected can be done at a much effective way, which is the most cost effective way can be done. And the next phase, the development phase, where you need to assess the technical feasibility, the approval from the firm, and also the recommendations from the top management. That is where the development phase comes into play. The next phase is the presentation phase, where the value engineering engineers will present that to the decision makers, and that will also be communicated to the all the stakeholders. Stakeholders here refers to the workers, the managers, the corporate in charges, all those people who are involved in those decision making. Once that information is disseminated, then it is about implementation of the same. All the necessary funding for the same has to be done, and the management has to take responsible of providing all the necessary fund, and the idea will be translated into actions into SOPs refers to the standard operating procedures, and then the responsibilities will be allocated, and the progress this has to be monitored. That is where implementation phase is very crucial, because up to creation and fixing up of your alternatives, it is quite an easier way of doing it. But once you have decided that is to be the alternative to be done, you have to ensure that that is implemented to a more successful phase. Once the implementation phase is done, you then look up for the actions, you audit that, you see whether the results are in line with your required output. If in case they are not in line, you have to look for what are the root cause analysis has to be done, and what are the cost optimal methodologies that could be followed to ensure that the process is much more optimized for the benefit of the firm. So when you speak about value engineering, one key important tool to be discussed is value stream mapping. It is called as VSM. What VSM gives you, it helps you to visualize more than a single process level, all the materials, the informations, and the people who are involved with. You usually call them to be the 4M: men, machine, material, and money. All these 4M's will be interrelated and they will be linked. In a simpler term, it gives a blueprint for implementation to the engineers, and it is more focused towards implementation of lean concepts and other techniques. So it brings in all the quality tools, all the industry tools put together. And one of the key important feature of VSM is that it follows a production path from the beginning to the end, which means that it gives a clear visual representation of each and every process, inclusive of the material and the information related to the particular process. Once the information is very clearly visible, there are few icons which are designed for creation of current state. Current state includes displaying or what is the information which has been observed correspondingly to the icons and the materials and the informations as well. As once that is done, then you go on to the future state map, how you can value and how the ideal process flow has to be. That is what your future state map gives you. The current state map and future state map are depicted here. I'll give an overview about how a current state map is about. So when you are looking for a material flow icon, this is how it is incorporated. If you see a completely square box, you see that it is an assembly which is done and the manufacturing process is done within the industry. And if you see this kind of symbol, it indicates that it is an outside source which has been done. And a push arrow indicates the product is moving from one work cell to the other work cell. And this is a truck shipment, and which is inclusive of which indicates the movement of goods within and outside the industries, and this is the finished goods to the customer. You could differentiate the food. If it is a push arrow with a dotted or probably a black colored arrow, then you see that to be an work in progress inventory or probably a goods inventory, which is movement of goods within the industry, and this is the finished goods which is transported from the industry to the customers. And how it is followed is usually the FIFO concept, which is first in first out sequence flow is generally followed. Whichever is coming first has to be moved out. That is the concept of first in first out. And this is the symbol of operator and buffer or safety stock. Few of the symbols you can relate to the third links which we have studied in unit 3 and unit 4. Right, and how the information flow is represented. The manual information flow is represented by the single arrow mark. An electronic information flow, which any information which is transmitted will be indicated in this particular symbol. And for a weekly schedule and load, which is leveling or unloading, all these are the particular symbols in which it has been represented. So once the current state map is done, then you are moving on to the future state map, where you are designing your own kind of setup, where you see that the product family is identified first, then you are looking up to upgrading yourself. So the ideal objective is that 70% has to be updated, and you have to predominantly use pencil, because you see that most of the time you may need to recorrect that, right? So it is about constant upgradation. So it is ideal that you use pencils for following the ideal flow conditions. Material information flow has to be very clearly mentioned, and it serves you as a blueprint. So you have to begin by drawing the current state map. First iteration usually assumes that the existing steps in equipment are ideal, right? So that is your first iteration. So second iteration is where you think about, see now, even for moving, you can apply VSM to any particular process. I will put it on a very easier example. Even for moving up a table from your in your room to your next room, you are planning to move your study table from room 1 to room 2, then you have to follow value stream mapping for all the materials and information flow has to be mapped. So you can see that the first iteration assumes that current place is the ideal place. So once that is done, the second iteration you have to think about alternatives of combining that task and combining the process, where you can move the one phases from one part to the other part. right? So these are the basic icons which are used in your realistic mapping. And once that is done, then you see that the future state map was quite possible, and it gives you a clear cut idea about how the flow is happening, starting from your material flow as well as to the information flow. What are the potential savings of implementing a VSM? I'll put up an example for you in the next forthcoming slides, where you could see the difference between how the system, the process is about when the value stream mapping was not implemented, and after value stream mapping implemented, how the process has been redesigned and how it has been optimized. But before that, we will see what are the potential savings of implementing a value engineering. You could see that the savings from value engineering cost of implementation is usually high, and once you will see that the net loss keeps on decreasing to a particular level. So once it is done, what is depends upon the project to project, and once you see that the net loss has declined further, the resistance lines keeps on increasing. So the cost of savings keeps on increasing over a time period. So initial stage, it is about investing so much of cost so that you cannot get the benefit in a very shorter time. So once you start doing the practice as an day long practice, or it is being regularized in your industry, you see that after a few months of time, or probably few years of time, when value engineering time and B is performed, it takes you time to see the monetary benefits. But once you see that, you could see that it keeps on increasing to a greater extent. So of course this graph depends on project to project, but usually this is an ideal project curve where you see that as the time increases, the savings through which value engineering is benefiting the company keeps on increasing. We'll stop with this and we'll continue the remaining part in the next video.